This video looks at the correlational method, which is part of the biological psych. You need to be able to define the term correlation and know why and how correlations are used. You also need to be able to distinguish between positive and negative correlations or identify where there is no correlation. You will also need to be able to draw a scatter graph in order to be able to assess a correlation and have an understanding of what statistical test is used to test significance on correlations and why it's used. So what is a correlation? A correlation tests the relationships between two variables. So, for example, to test the relationship between basketball players and height, one participant will provide the data for both. It's important to note here that there is no independent variable or dependent variable. It is not looking at cause and effect. It is not suggesting that one, the independent variable, will cause an effect on the dependent variable. It is just looking for a relationship between the two. Now these two are what we call covariables, which will exist alongside each other. Now correlations are useful because they allow us to test whether two or more phenomena are related, but also how strongly they are related. Correlations in the spec was originally included in the psychodynamic approach and is now included in the biological approach. Now this is interesting because Freud himself didn't use this methodology, but it's often been used to test some of his ideas. Correlations often rely on self-report data, and this is quite important. Now, self-report data is data that a participant will provide about themselves, for example, through a questionnaire. Now, it's useful in questionnaires to use rating scales because they produce ordinal data. So when to use a correlation? Now, a correlation will be used to test a hypothesis about a relationship between two variables. So an example, for the taller a person is, then the heavier they will be. When looking for a relationship, it's unethical to test. So, for example, in your biological approach, you've been looking at testosterone. Now, this would be unethical to test because you can't give people injections to increase their testosterone levels and then send them out into society and see if they're more aggressive. Also, note with your exam, things like smoking or alcohol consumption, any sort of use of drugs, again, would be unethical to test on humans. So what we do instead is see if there is a relationship between the two. Correlations can also be useful if you need to test reliability. So scores of a group can be correlated against scores from the same group that were used at a different time. Equally, within the biological approach, they help us to compare the effect of monozygotic twins, which are identical twins, to support the theory of inherited differences in intelligence or psychological illnesses such as schizophrenia. Now, a correlation will always be produced on a scatter graph. Now, this is where the values are plotted by x's to show the variables. Now, the x-axis, which is the one down here, the one that goes across, will show here on height, and this y-axis here will show the shoe size. And you can look here that where all the plots have been pointed, they go in a line up, and that suggests a positive correlation. Now that means as one increases, so does the other. So for example, if we were to look at somebody with a height of 7 foot, we would go up here, and that would show us that they are likely to have a shoe size 7. Obviously this isn't based on accurate data, but you can see that as one increases, one variable increases, the other increases with it. Now this is an example of a positive correlation. Now a positive correlation are when both variables will increase together. So as one gets bigger, the other gets bigger as well. Examples may include the taller a person is, the heavier they're likely to be. Well, the most important one for me is the more revision you do, the higher your exam grade will be. The line that I've drawn on the screen, which I've drawn on all the correlations, is what we call a line of best fit, which you draw through the plots that you point to see how strong a correlation would be. A negative correlation, as you can see on the screen there, is a correlation that goes down. This is because as one variable increases, the other will decrease. So as one gets bigger, the next one will get smaller. So for example, the more you practice an instrument, the less mistakes you will make. The younger you are, the more text messages you are likely to send. Or the more alcohol you drink, the less you are likely to remember. And again, you can see the line of best fit going through the points that we've plotted. Now this is an example of a scatter graph that will have no correlation. This can be easily demonstrated because I cannot draw a line of best fit through the points on this graph in order to be able to show a correlation. They're sporadic, they're spread out, there is no relationship there. Once you've done a scatter graph and you've been able to test whether you think there's a correlation or not, The statistical test that we do on correlations is called Spearmans Rho. Now, Spearmans Rho gives us a value to tell us whether or not our correlation is significant or not. Now, if we were to get a value of +1, that would be the strongest positive correlation that we could get. If we were to get a value of -1, then this would be the strongest negative correlation that we could get. If we find out through Spearmans Rho that our results are significant, then this means that there is a relationship between the two variables that we've been testing.